Hello dear students, welcome to Physics Plus Maths with Dr. Sajuket on YouTube channel. This is the first class of class 12 physics. In this class, we will start with the first chapter in the NCERT syllabus, which is electric charges and fields. First two chapters are dealing with electrostatics, Uh, in this chapter, first I will explain what is electrostatics. Then I will go to the different charging methods to charge a body, used to charge a body. Then I will come to the friction electricity and another method used to charge a body, which is conduction. Okay, so I will come to these topics one by one. So for our first question is electrostatics. For simplicity, I am going in a question and answer pattern. Okay, so what is electrostatics? The word electro means charge. So I am splitting the word electrostatics into two. Electro means charge, and the word statics, this part, statics means stationary. So electrostatics means the study of stationary charges. Stationary means charges at rest. Okay, so what is electrostatics? It's a branch of physics. It's a branch of physics which deals with the charges at rest. So you got the definition of electrostatics. Electrostatics is a branch of physics which deals with the charges at rest. Okay, when the charges are moving, we have another branch which is called the current electricity. Okay, electricity or the current electricity. This is the static part of electricity, which is called the electrostatics. Yes. So next we are going to the charging methods of a body. Actually, there are three charging methods to charge a body. The first one is, I will explain the three. The three charging methods are, first one is rubbing. When we rub two materials, they will be charged. Then it is conduction. Then induction. I will explain all the methods one by one. So what is a method? I told you there are three methods to charge a body. Generally, there are three methods. First one is the rubbing or charging by induction. It is called the frictional electricity. When charges are obtained by rubbing, it is called frictional electricity. Frictional electricity, which is the first method. Then there is conduction and induction. After this, the question is, what is the method to charge an insulator? To charge an insulator, which method can be used? This frictional electricity can be used to charge an insulator. For insulators, there are mainly two materials. The conductors, which easily pass electricity through them without much resistance. But insulators, they offer very high resistance towards the passage of electricity. So insulators, which method can be applicable in the case of insulators? The first method is meant for insulators, and the second two methods, the other two methods are for conductors. Okay, so we got the answers. Rubbing or the frictional electricity is for insulators, and the other two methods are used to charge conductors. Okay, then now we are going to the frictional electricity. What is meant by frictional electricity? Frictional electricity, give an example. Okay, I will explain that. See this example. When a glass rod, frictional electricity is the charge obtained by a body on rubbing with another body. The charge obtained by a body on rubbing with another body is called frictional electricity. Okay, so when two bodies are rubbed, because of friction, charges are developed in those bodies. It is called frictional electricity. For example, when a glass rod is rubbed with silk, glass rod is charged as well as the silk is charged. Okay, so I will explain that. When glass rod, suppose this is a glass rod, it is rubbed with the silk. Glass rod is rubbed with a silk material. Then what happens is that when they are rubbed together, heat energy is developed. Because of friction, heat energy is developed, and absorbing that heat energy, taking that heat energy, electrons will be transferred from one material to another material. Here what happens is that electrons will be transferred from glass rod to silk. The electrons will be transferred from glass rod to silk. Okay, when we rub glass rod with the silk, what happens? Electrons will be transferred from glass rod to silk. So what happens is that since electrons are moving from glass rod to silk, when one electron is moving from glass rod to silk, glass rod is positively one positive charge it gets, and the silk gets one negative charge. When two electrons, if two electrons moves from glass rod to silk, glass rod is gets two positive charge, silk get two negative charge, and so on. Suppose five electrons have moved from glass rod to silk, then five positive charges. Glass rod will get 5 E charges. Actually, this E is an amount of charge which is 1.6 into 10 raised to minus 19 coulomb. Actually, this is the charge of an electron. Actually, the charge of electron is a negative charge. When there is a negative sign, it is charge of electron. Otherwise, it is that much positive charge. Okay, so electrons are transferring. We denote this number as E. Okay, so the glass rod, when 5 electrons are transferred to silk, glass rod will get plus 5 E charge, and silk will get how much charge? Minus 5 E charge. Okay, minus 5 E charge. So how the glass rod and silk are charged on rubbing? When rubbing, what happens? Heat energy is developed. Taking that heat energy, electrons will move from one material to another. From which material to which material? Out of these two materials, electrons will move from that material in which the electrons are loosely bound. Okay, if the electrons are strongly bound in a material, electrons cannot get free from that material. So in what material the electron is less or loosely bound, from that material electron will be moving to the other material. That means in this case, in glass rod, the electron is loosely bound, so electrons will be coming out of the glass rod, they will stick to the silk. Okay, so the bodies get charged, these two bodies get charged by the transfer of electrons. Transfer of electrons happens. Okay, actually, in different other materials also, this frictional electricity or charging by rubbing can happen. Actually, the charge was discovered by this kind of an experiment. Experiment means the people rubbed amber with wool, then amber gets charged as well as wool gets charged. Okay, both amber and wool got charged. Okay, that is the amber. Amber is a fossilized tree resin that has been appreciated for its color and natural beauty since Neolithic times. Okay, so amber is a tree resin, fossilized tree resin. It's a beautiful gemstone. Okay, when it is rubbed with when people rubbed it with a woolen cloth, the amber gets charged. It could attract small paper bits, fibers, etc. Okay, the actually the name electron, it's a Greek name. That is the difference. That is why there is a different spelling with English. So electron, it came from the word amber. Okay, so electron is the Greek name for amber. From this the name electricity originated. Okay, so when amber rubbed with wool, amber got a charge and wool also got a charge. Okay, so now we are going to other examples of materials which can be charged by rubbing. We discussed the case of glass rod and silk. Actually, I have classified the materials into two. uh, the materials in column 1, when they are rubbed with column 2, will be positively charged. The material in the column 1 will be positively charged when rubbed with the column materials in the column 2. I mean, when glass rod is rubbed with silk, glass rod is positively charged and silk is negatively charged. Similarly, when wool is rubbed with amber, wool is positively charged, amber is negatively charged. And when wool is rubbed with ebonite, wool is positively charged and ebonite is negatively charged. When wool is rubbed with the plastic is negatively charged, wool is positively charged. Similarly, when ebonite is rubbed with polythene, what happens? Ebonite is positively charged, polythene is negatively charged. When dry hair or fur is rubbed with the comb, what happens? Uh, dry hair is positively charged and comb is negatively charged. Similarly, so the materials in the column 1 gets positively charged when rubbed with the materials in the column 2. So this is the case of frictional electricity. So uh, uh, in frictional electricity, what do we understand? How does a body get charged? We got the answer for that. How does the body's glass rod and silk got charged? By the transfer of electrons. What happened? From glass rod to silk, electrons transferred from glass rod to silk. So glass rod became positively charged and silk became negatively charged. So what is the answer for this question? The body gets charged by the transfer of electrons. Okay, how does a body get charged? A body gets charged by the transfer of electrons. Which body is positively charged? The body which loses electrons gets positively charged, and the body which gains electrons gets negatively charged. Okay, which body is negatively charged? The body which gains electrons is negatively charged. Okay, so you got the answer. Now there is a question: is the mass of a body affected by charging? Suppose you are asked this question: uh, is the mass of a body affected by charging? First you will say no. Okay, but if you think, there is a slight change in the mass of the bodies when they are charged. Okay, as compared to the mass of the bodies when they are in neutral state. Okay, so we study the case of a glass rod rubbed with the silk. Glass rod and silk. Okay, suppose 10 electrons are transferred from glass rod to silk. How many electrons? 10 electrons. 10 electrons. So what will be the charge of glass rod? It will be plus 10 E, right? What is E? E is 1.6 into 10 raised to minus 19 coulomb. What is the importance of this charge? This is the smallest charge that can be transferred from one body to another. This is the smallest charge that can be transferred from one body to another. When I said this is the smallest charge, somebody will have some confusion, because in higher physics we study about quarks. We study that quarks are made up of the nucleons. Nucleons are made up of, nucleons means neutrons and protons. You know, the particles inside the nucleus, which are neutrons and protons. Protons. When we study the quark structure of proton is made up of 3 quarks, which is UUD. 2 up quarks and 1 down quark, up and down quarks. And when we study the charge of a neutron is made up of UDD, 1 up quark and 1 down quark. The charge of up quark in the intermediate level or class 12 physics, we don't need to study this the quark structure or anything. So I'm just telling for your knowledge. When I study the charge of when I say E is the smallest charge, there is a problem. But I can say that the charge of electron, or 1.6 in 10 raised to minus 90 coulomb, is the smallest charge that can be transferred from one body to another. That is clear. Okay, I will explain that. The charge of U is plus 2 by 3. Okay, so it's a fraction of charge of electron. 2/3 of the charge of electron, and the charge of down quark is minus 1 by 3. Okay, minus 1 by 3. Okay, so when we study this quark structure, smaller charges are present, but they cannot move from one body to another. Okay, they're not free to move from one body to another. So the charges which are transferred from a body, the smallest charge that can be transferred from a body is the E, which means it's 1.6 in 10 raised to minus 19 coulomb is the smallest charge that can be transferred from one body to another. So when 10 electrons are transferred from glass rod to silk, glass rod gets plus 10E charge and silk gets minus 10E charge. Okay, so the electrons have mass also. Even though the mass of electrons is very small, electrons have a definite mass, which is 9.1 into 10 raised to minus 31 kilogram. This is the mass of an electron. It's a very, very small mass, but electrons have a definite mass. So we can say that when 10 electrons are lost for the glass rod, its mass will decrease. The mass of glass rod will decrease by an amount of how much? 10 times mass of electron, right? And for the silk, what happens? The mass of silk will increase by an amount of 10 times mass of electron, right? Even though it is a very small quantity, there is a definite change in the masses of the two bodies when charged, as compared to the states or the masses when they are in neutral. Okay, so uh, we can say that when a when a body is charged, if it is positively charged, its mass decreases, and if it is negatively charged, its mass increases. So generally we can say the mass of the body, the final mass of the body, will be the initial mass of the body, like this mf and I will mi, uh, plus or minus ne. Okay, the plus goes for the positively charged body, sorry, negatively charged body. The mass of the negatively charged body increases, and the mass of the okay, uh, uh, positively charged body decrease. I mean, the mass of the, for positive charged body, the final mass is initial mass minus ne, and for the negatively charged body, the final mass is the initial mass plus ne, right? Okay, so we can write the answer like this. Yes, the mass of a body is affected by charging. A positively charged body loses electrons, therefore its mass decreases. A negatively charged body gains electrons, so its mass increases, because electrons have a definite mass. Okay, so I discussed about conductors and insulator. I told you that insulators can be charged by friction electricity. The other two methods are useful for conductors only. Which are the other two methods? Conduction and induction are useful for conductors only. So what are conductors and insulators? Anyway, I am telling some definitions. The materials which allow the passage of electricity uh, through them easily are called conductors. The materials which allow the electricity to pass them easily are called conductors. Example: metals, aluminium, gold, silver, all those materials, copper. The materials which offer high resistance to the passage of electricity are called insulators. The materials which offer a high resistance to the passage of electricity are called insulators. Okay, which are the examples? Non-metals like glass, porcelain, plastic, nylon, wood are insulators. Okay, so you got an idea about conductors and insulators. Conductors cannot be charged by rubbing, but insulators can. Why? Conductors, suppose you have a copper plate or a key, which is a metal. Uh, if you rub the key with your hair, it will not be charged. You cannot attract small paper bits with that. But if you rub your plastic pen with your hair, it will be charged, and you can attract small bits of paper, small fibers of clothes, etc. What what is this? What is the reason for that? When conductors are rubbed, what happens is that conductors will be charged. When a metal plate is rubbed, like suppose this is a copper plate, when it is rubbed, it will be charged, but the charges will be distributed all over the body, all over the surface of the conductor. But if it is an insulator, suppose it's an insulator, what happens is that the charge will remain at the same place. Okay, at the small region, the charge will be there. It cannot flow through the body because it's an insulator. So it will not be uniformly distributed all over the surface of the body. But in the case of conductors, the charge will be uniformly distributed all over the surface of the conductor. So the effect of charge will not be felt, because a small amount of charge is good for the body, and it is uniformly distributed. So the effect of charge on the tip of the conductor that you have rubbed with your hair will be very less. Also, if you hold the conductor with your hand, what happens is that the charge will be conducted through your hand to earth, through your body to earth. So the charge will be earthed. But in the case of insulators, what happens? The charge will remain at the same place where it is got. Okay, so it cannot flow through your body. through the material. It cannot distribute over the material. It cannot flow through the body because this material is an insulator. It will not allow the passage of electricity. Okay, so this is the answer. The conductors cannot be charged by rubbing because when a, when some charge is transferred to the conductor, when some charge is put to the conductor or transferred to the conductor while rubbing, it readily gets distributed over the entire surface of the conductor. But if some, but in the case of insulators, what happens if some charge is put on a insulator? It stays at the same place. That is the difference between conductor and insulators, and that is why conductors cannot be charged by rubbing. For conductors, we have other methods. This is one of the methods that can be used to charge a conductor, which is conduction. There is another method, which is induction, that I will explain the as a next class. Okay, what is conduction? Conduction is very simple. Conduction means flow. Conduct means flow. Suppose you have a charged body, any charged body. It can be a conductor or insulator, but it should be charged. A charged body. Okay. When it is brought in touch with the conductor, when it is brought in touch with the conductor, let it be a copper or aluminium. Okay. So what happens is that the charge will flow from this charged body to this conductor. Charge will easily flow to the conductor so that this conductor is charged. But you have to keep the conductor not in your hand but over an insulator. Why? Otherwise the charges will flow to earth. So we have to keep the conductor over an insulating or isolating stand. Insulator over an insulator, then the charge will remain there in the conductor. So what is the conduction? When a charged body is brought in contact with an uncharged conductor. This charged body brought in contact with an uncharged conductor, charges flow from the charged body to the uncharged body. The charges flow from the charged body to this body. That process called conduction. So this is the method of conduction. Okay, so in this class we discussed about what is electrostatics. We understood what is electrostatics. What is electrostatics is the branch of physics which explains with charges at rest. So in electrostatics we study about charges at rest only. Okay, and we studied that the charge of electron is the smallest charge that can be transferred from one body to another, 1.6 into 10 raised to minus 19 coulomb. We studied that there are three methods for charging a body, which are the three: rubbing or frictional electricity, then conduction, induction. We explained what is frictional electricity. When two bodies are rubbed, when two insulators are rubbed, charges are obtained on the two bodies by the transfer of electrons. One body will be positively charged and the other body will be negatively charged. We understood that the body which loses electrons is positively charged and the body which gains electrons is negatively charged. Okay, we understood conduction also. What is conduction? Conduction is the process in which a charged body, when it is brought in contact with an uncharged one, charges will flow from the charged body to the uncharged one. That is called conduction. Okay, thanks for watching this video. We will meet in the next class. Thank you.